Thanks for tuning in at Brackies.
Hello everyone and welcome to the first video on creating a multiplayer FPS in Unity. So this is a subject requested by so many of you guys, and I thought I would finally go ahead and cover this in a series. And it's a great time to do so because Unity quite recently released UNet or Unity Networking, which is their new networking solution, and I can tell you it's actually pretty great. So that's what we're going to be doing, and we're going to be creating the game in C#. And I do expect you to have some understanding of basic Unity concepts and programming concepts. But that being said, I will explain a lot of stuff along the way, as much as possible. Cool. So before we go ahead and get started with today's video, which is setting up our player and the player controls, I just quickly want to mention that if you want to support me and this series and the other series I've going, you can go to brackies.com, and I do have a donate button here. It helps out a lot and keeps me going. And also, if you have any questions throughout this course, I suggest you go to forum.brackies.com, where you can make a post or a topic here, and you will almost certainly get some answers. Cool. So I just quickly want to give you a taste of what it is we're going to be making. And I don't know how much of it we're going to be able to cover in this first video. But you can see here I've made this test scene, and this is just a project I use for testing some stuff out. And this is the actual player. And I know that he looks kind of funny, but I was thinking that we could make this kind of sci-fi-like and make him some kind of spherish robot with a thruster down here, and have the weapon rotate around this sphere. And therefore, because he's kind of levitating in the air while we play, I've made the controls almost spring-like, and I've made him given him the ability to fly. So we have these thruster force and fuel and regen speed and controls down here. And you can see that I've created a player motor and a player controller script, which actually controls his movement. So that's what we're going to be looking at today. And if I go ahead and hit play here and drag the game over here so you can see what's happening to the controller, you can see that we can look around like this. We can also, of course, move around, and this is not smoothed out yet. That's something we can do in a future video. And then you can see that I can fly away here. And when I run out of thruster, I simply fall to the ground. And you can see just how smooth that is when I use the thrusters here. And that's something you can completely control, how much dampening and spring effect you want on that. But I think this should give some really cool controls that are not just like any other FPS. Cool. You can, of course, use this tutorial for creating a completely ordinary first-person character, but then you might as well use the standard assets one. Cool, so let's go ahead and close down that project. And I've created beforehand here a new one called Multiplayer FPS. It's a completely empty project, and I just set the defaults to 3D. And in here you can see I have an empty project folder. So let's go ahead and right click on that, import package, and then environment. And this will just allow us to use some of the, not in environment, that was wrong, import package prototyping. Because Unity has some quite nice prototyping prefabs like the floor plane and some of the cubes that you saw me using. And you can see that if you go under standard assets, prototyping models, there are a lot of different stuff that we can use here. So let's just take the big floor prototype, the 64 by 64, and drag it in here. And let's also take a couple of cubes, maybe the 4 by 4 ones, and just place them on the ground. So let's just place one there, duplicated, move one over here. And let's take a smaller one too. Whoops. Is that bigger? That's a lot. Nope. It's just being placed wrongly. So let's just drag it in here and reset the transform. There we go. And we can just drag it over here. Just so we have something to orient ourselves in the scene. And right now all of the colors here are fairly boring, and that's something we can change soon. For now, let's just get cracking on the player controls. So up here, let's create an empty game object. Let's reset the transform on this, and let's call this underscore environment. You don't need the underscore here. It's just a habit of mine whenever I create these kind of grouping objects. But actually, let's just go ahead and delete that. That's unnecessarily confusing. And let's just take all of this stuff, including the light, and drag it under there. So now we have this clean hierarchy up here, and the main camera, which we are going to just delete, because we're going to be creating one for the player instead. And because I excessively save all of my scenes, let's press Ctrl S and just save the scene here. So I'm just going to call this main level 1 so far, because we don't know what this is actually going to be doing yet. Cool, so let's start building our player. So we are going to start completely from scratch, and we are going to do so using a sphere. So let's right click on this, go under game object, or 3D object, sphere, reset the transform on that, and let's set the position on the y-axis to 1. And this looks nice already. And let's go ahead and remove the mesh renderer and the mesh sphere here. And let's create another object under this, an empty object. Again, make sure that's reset. And let's rename this to graphics. And under this, we create another sphere. And we remove the collider on this. So this way we have the graphics separated from the collider, and we can move those separately. That's just a nice thing to do. So we can call this player model here. And this is of course temporary. And then the sphere here, we can go ahead and call player. Awesome. So we're going to need a bunch of stuff on this player. First off, we're going to need a camera. So let's just create a camera object, and that's going to sit inside of our sphere. So just reset the transform on that, and that should be fine. And this has all of the default settings, which are going to be fine for now. And so that we know which way our player is facing, let's go ahead and create a temporary gun model under this camera. So let's right click, go on the 3D object, select cube. And let's give this a cool darkened material. So let's go down here, right click, create material, and let's call this gun material for now. And let's change the albedo to a grayer color here and drag it, oops, make sure you drag it onto the cube here, like this, and let's make it kind of dark. And that should be just fine. And the smoothness here, I'm going to drag all the way down so that this isn't shine. Okay, we can give it a bit of shine there. That looks fine. And we can go ahead and rename this. Actually, let's create another object here, another empty object. Reset that. Let's call this one gun. And let's drag the cube under that gun object. We can then move this out. And then we can start modeling our gun here. Awesome. So now that we have that in place, we can go ahead and actually create some logic for our player, because right now when we play the game, of course, nothing is going to happen whatsoever. So we can start out by creating a rigid body on our player, our root object here. And we can set the mass to 1, that's fine. I do want some drag, but we're going to leave it at 0, and then I'll show you what drag does later. So constraints, we're going to freeze all of the rotation, because that's only going to be driven by our mouse. But I don't want to freeze the position, because I want to be able to be affected by stuff in our scene when it comes to position. Then we want to uncheck use gravity, because we want this guy to be floating. And we're going to make the nice bounciness using some kind of spring component, but that's something that we'll add in later. So this should be the basic setup for our rigid body. And then I want to make two scripts. So the first one is going to be our player motor, new scripts of type C#. And the second one is going to be our player controller. So when it comes to movement, there is a million ways of doing things. And I've tried here to find a nice balance between optimization and readability. So when it comes to like thinking about how we want this movement to work, I think it's logically a great idea to split it up into two scripts. We have the controller, which handles all of the input and stuff like how much fuel is left, are we jumping, what way should we be looking. And then we have the motor, which simply has a set of functions which will move the player, make him jump, and make him fly, all of that. So that doesn't handle any of the actual input. It's just kind of, you could call it a utility script that will take directions and velocities and all that and apply them to the rigid body. So that's kind of the way you should look at these two scripts. You have the controller and the actual motor that drives it. And if we go ahead and double click on these, it's going to open up in Visual Studio. And yes, I'm using Visual Studio. It's something that comes with Unity now. And if you want to be using Visual Studio instead of Mono Develop, which I do recommend that you do, then go under Edit, then Preferences, External Tools, and choose Visual Studio 2015. And if it's not there, you can browse for it. Cool. So it's opening up Visual Studio here and should be ready in just a second. And there we go, it loaded on my other screen. And let's just load up the player controller too. So we have these two right here. I'm just going to close the scripting API. So the player motor is going to require a component type of rigid body, because we want to always have a rigid body with our player motor. I'm also going to delete that using statement there because it's not needed. And in here, we are going to have some methods for actually making our player move. But first off, let's look over in the player controller. Well, the player controller, we can delete that too, is going to require another component, and this is going to require type of player motor. So when adding a player controller, it's going to add a player motor, which is going to add a rigid body. We've already added a rigid body, but just in case, it's a good idea to do it like that. Awesome. So the first thing that we are going to be creating here is the actual movement. So we can start out by making a serialized field, private float called speed, and set this to something like 10 or maybe 5 is going to be fine. And if you don't know, marking something as serialized field will basically make it show up in the inspector even though it's set to private. So this is the exact same as doing public serialized field, even though it's still, but it's still protected. So that's really good. So then we can make a private reference to our player motor, and we'll just call this motor. And we can set this in the start method. We'll just set motor equal to get component player motor. And this is where the required component is really awesome, because we don't have to do any checking or error handling. We know that there's going to be a player motor on this game object. Then inside of our update method, void update, we are simply going to calculate our movement velocity as a 3D vector. So basically, we're first going to get our horizontal movement. So we're going to store that as a float. And let's just call this xMove. And the underscore here is, of course, optional. I just like to do this with variables created within a method. So xMovement is going to be equal to input.getAxis and I'm going to choose get axis raw because I want to do my looping on my own. So if we want any kind of smoothing here, it's good to be in complete control on of how we do that. And if you use get axis, well then Unity is going to perform some processing on it and you won't be in full control. So by default, let's get the raw axis and then let's perform our own smoothing later. And the axis that we want to get here is the horizontal axis. Then we want another float, and we'll call this Z move, and we'll set this to input.getAxis raw and then vertical. And of course, the axes we are getting here are set up inside of Unity. So if we go in here, go under Edit, Project Settings, Input, Axis. And you can see here that we have the horizontal and the vertical. So that's where we're getting these from. And if you're not aware, whenever we use a keyboard or a controller, horizontal is going to go between -1 and 1. And vertical is going to also go between -1 and 1. So we can use those to perform our movement on the two axes. Then we're going to create a vector 3, and we'll call this move horizontal, and we're going to set it equal to transform.right. That's going to be our direction to the right, but this is going to be local. So when using transform.right instead of vector3.right, we'll take into consideration our current rotation, which way we are facing, and it won't just be relative to the world. So transform.right, and then we'll multiply this by our X movement. And we're going to do the same, make a vector here called move vertical, set it equal to transform.forward. So this is our forward movement, and we're going to set that equal to or multiply that with our C movement. So transform.right is a vector with the values 1, 0, 0, and the transform.forward is a vector with 0, 0, 1. And then we multiply this value into it. So if we don't move at all, this is going to be 0, 0, 0. If we're moving forward, then this is going to be 1, 0, 0. And if we're moving backwards, this is going to be -0, 0. So, or -1, 0, 0. And the same down here. So this is just the value that's going to change. So if we're not moving, if we are moving, and if we are moving backwards. That's the result of this calculation. So we can use this quite effectively to get kind of our local direction or our local velocity vector. And then we can combine these two into our final velocity vector. And we're going to simply combine them by saying move horizontal plus move vertical. And then we're going to normalize them and multiply them. Multiply them by our speed variable. So what we are doing here is we are combining the two. When normalizing, we're saying that, well, the length of these shouldn't matter. So when we are combining them, we are saying that the total length of this combined vector should be 1. And that means that we won't get a varying speed when multiplying these. We will always get a vector with the length of 1. And that basically means that we're only using this as a direction that we then multiply with a speed. Cool. And then we apply this movement. So this is going to be our final movement vector. And then we apply our movement. And we do this by calling some kind of function on the motor, and we're going to make this in a sec, and we'll just call this function move, and we'll pass in the velocity vector. So now we can jump over to a player motor and actually make this happen. So the video kind of went on for a lot longer than I had expected, so I'm sorry, but I have to cut this up into 2 parts. I hope that you will enjoy the next one as much as you've enjoyed this one, if at all, and I'll upload it as soon as I can. I'll see you in the next video.